the YouTube channel. As I said last time that I'll be more focused on dealing with grade 12s, right? So I asked around which topics would they like me to start with, and surprisingly a lot had been saying they're struggling a lot with Newton's laws and all that. So according to the way that I teach these Newton's laws and everything, I take it as one topic, right, which falls under mechanics, right? So I will help you with mechanics. But as we all know it, that mechanics is a wide broad that deals with a lot of things, right? It has many topics that falls under mechanics. So we have vectors. Vectors falls under mechanics. And we also have Newton's laws. And then we have vertical projectile. We have momentum. And lastly we have work, energy, and power. So in your final exam, the grade 12 final exam, we know that these topics, they hold up to 65 marks, right? They hold up to 65 marks of the total grade 12 paper, right? So I'll start to deal with vectors first, and then I'll go to Newton's laws, right? So vectors, I would subdivide them into two. The grade 10 part, which is grade 10, which deals with vectors in one dimension, right? And then I'll go to grade 11 work, which deals with vectors in two dimensions, right? So it means that for now I'll deal with grade 10 work. So I'm just trying to make these videos short and enjoyable so that like you won't spend a lot of time on one video, right? So I'll start to deal with the grade 10 one. So in the grade 10 vertical projectile, in the grade 10 vectors, what do we talk about in the vectors of grade 10? So I'll just try to give the definitions of few things and then I'll go on, right? So at first I'll talk about what is a vector to start with. What is a vector? So a vector is a physical quantity that has magnitude and direction. So I'll come back to this direction, because we all know that in physics, mostly when we're dealing with mechanics, direction is the most important thing. Once you get your directions wrong, you get your answers wrong, right? So you have to focus more on direction, right? So let's go on. Apart from vectors, also in grade 10 we learn what is a scalar quantity, right? What is a scalar quantity? So this is a physical quantity with magnitude only. So this one is magnitude only, right? So which are the things that we're talking about when we're talking about vector quantity and scalar quantity? In vector quantity, I'm interested in this, that I'll be talking about a lot. We'll be talking about force a lot, right? So force is a scalar quantity because you can say that an object is pushed by 5 newtons to the left or to the right. So that 5 newton is the magnitude, and then to the left or to the right it is the direction, right? So everything that deals with vectors is direction, right? And when we're dealing with scalar quantity, we talk about things that don't have direction. For example, the mass, we can only say that something is 5 kg. We don't say to the left or to the right, right? So it's just a scalar quantity, right? So I'm sure you can see the difference between a vector and a scalar, right? So let's go into details about vectors. So vectors are used to represent any physical quantity that has magnitude and direction. So vectors are used to represent any physical quantity that has magnitude and direction, right? So again, I'll underline this direction so that it will stay at the back of your mind that we're always dealing with direction, right? So I said in this topic mostly I'll be using force as our vector, right? So in grade 10, as I said, we are going to do vectors in one dimension. In one dimension. So we're talking about collinear vectors. Collinear vectors. What are collinear vectors? So collinear vectors are vectors that are parallel to each other, right? Apart from that, they are also in the same plane. They're acting in the same plane. For example, if I deal with vectors that are like this, so these are parallel to each other and they're working at the same plane, right? So they're going either to the left or to the right. As you can see, this is going to the left and this is going to the right. So these are collinear vectors. And I can also represent them by up and down. So if I'm having something like this, so these also they are collinear vectors. So all collinear vectors can be shifted into a straight line, right? So all collinear vectors can be shifted in the same line. So it depends on how many vectors we have, but after all we are going to put them as in a straight line, right? So what are we mostly interested in when we're talking about vectors? When we're talking about vectors, we're mostly interested in finding the resultant vector. The resultant vector, right? So we're mostly focused on finding resultant vector. So what is a resultant vector? What is a resultant vector? A resultant vector is a single vector that has the same effect as the other vectors acting on a single object adding up. So a resultant vector is a single vector that has the same effect as the other vectors acting on a single object adding up, right? So I can be having 5 vectors acting on a single object, right? Maybe I can be having 1, 2, 3, 4, 5 vectors, right? So I'm having 5 vectors here, right? So as I'm having 5 vectors, I can have one vector that represents all these vectors. Maybe it can be like this. So this vector can be seen as the resultant vector because it is representing all the vectors, right? Or we can simplify this meaning by saying resultant vector is the sum of all vectors acting on a single object, right? At this moment you may be a bit confused like how is this going to work, but I'm going to show you how this is going to work, right? So just bear with me and let me show you how this is going to work so that you can find the resultant vector, right? Okay, so how do we do this to find the resultant vector, right? So we use the method that is called head to tail method, right? So we use head to tail method, or some they call it tail to head method, right? It's still the same thing, right? So I'm gonna deal with this, and again don't forget that we talked about direction, right? So I'm gonna also tackle it right now when I'm showing you this, right? So let's say for example we are given that we are having a trolley that is here, right? we're having a trolley and kids are playing with this trolley. So the boys are pushing this trolley to the other side and the girls are pulling it to the other side as well, right? So let's see. So we're having 3 boys here. This one is pulling this at 3 Newton, as you can see. So this is our force number 1, and then our force number 2, this kid is also pulling at 2 Newtons, so this is force number 2, right? And the third one is pulling this at 6 Newton, and this is our force number 3, right? So it means that the ones that are going to the right, there are 3 forces, right? So let's see the ones that are being pulled by girls. So this girl pulls this at let's say 4 Newton to the left, right? So this is our force number 4, and then we're also having this force number 5, which is 5 Newton, right? So having 5 forces acting on a single object, which is a trolley, right? So how are we going to find the resultant? It is very much simple, right? So as I said, we're going to tackle this matter of direction, right? So as you can see, we're dealing with right and left, and these are collinear vectors, right? I said collinear vectors, they are vectors that are parallel to each other. These are parallel to each other, right? And they're acting on the same plane. So on the same plane, I mean either left or right, up or down, east or west, north or south. Those are what? Same planes, right? So direction. So in physics, if right now I'm talking about left and right, right? So if I chose my right as positive, right? This is how we're talking about when we're talking about direction. It means that our left is going to be negative. So our right is positive, our left is negative. So how are we going to find the resultant vector? So to find the resultant vector now, as I said, the resultant vector is the sum of all vectors acting on what? On a single object. So this is our single object, and we're having 5 vectors acting on this object. So we're going to add them up, right? So I'm going to say force 1 plus force 2 plus force 3 plus force 4 plus force number 5, right? So this is, what is force number 1? Force number 1 is 3 Newton. This is positive, it is going to the right. So I'm going to put positive 3 plus force number 2 is 2 Newton, which is going to the right as well. So it's positive 2. And this one is going to the right as well. So it is positive 6 plus. And this one is going to the left now. And we said our left is negative. So this is going to be negative 4. And lastly, we're having this, which is going to be negative 5 Newton, right? So this will be 3 plus 2 plus 6, which gives me 11, right? And then minus 4 minus 5, which gives me minus 9. So this is going to be 2 Newton, which is positive, right? And now we go back to our direction. We said if it is positive, it means that it is going to the what? To the right. So it means that our resultant vector now will be equal to 2 Newtons to the right. So we've dealt with the magnitude and the direction, right? So dealt with the magnitude and the direction. So this is how I mean when I'm talking about direction. Can you see how we tackled the direction on this one, right? So this is how we are going to deal with vectors from now on up until, right? So these are just few notes on how you can do this when you're dealing with vectors, right? So it means that at first you can just make a sketch on the situation, right? And then you count how many vectors you have, right? And then from counting how many vectors you have, what's the next thing? The next step is choosing your direction. Choosing the direction. So it's either your right being positive, then your left automatically becomes negative. Either not being positive, then your south automatically becomes negative, right? And then from then, we find our resultant vector by adding up vector 1 plus vector 2 and so on, depending on how many vectors you be having, right? And then lastly, you find your resultant vector, and don't forget your direction, right? As I said, direction is the most important thing when we're dealing with vectors, right? So apart from this, there's nothing else that is there in grade 10. So it means that if you're having questions, you can leave them in the comment section. But for now, just wait for vectors in 2 dimension for grade 11 work. So again, guys, don't forget to subscribe, right? So subscribing really shows us your support, right? That you're supporting this page. So see you on the next one. Thank you for watching this.